Methane is a leading cause of climate change. Due to its dangerously strong global warming capacity, spotting and cutting methane today can safeguard our climate future. Methane comes from a variety of sources, including coal, oil, and gas operations, as well as livestock, farming, and landfills. Studies indicate that about half of regional methane emissions come from strong point sources, also called super emitters. The worst of these hotspots leak at disproportionately high rates, sometimes thousands of times more than other emitters. Companies and policymakers are rushing to develop better ways to pinpoint and tackle these super emitters. And a new generation of remote sensing satellites is overcoming challenges. In the past, not all methane monitoring technologies had the sensitivity or resolution to pinpoint methane from specific facilities. Also, monitoring must be frequent enough to reliably capture both steady and intermittent emissions. Lastly, there's the sheer scale. Many thousands of super emitters like landfills, agriculture sites, and fossil fuel infrastructure likely exist around the world. These gaps in coverage mean that, till now, we've only had partial knowledge of super emitters' location, scale, and behavior. Today, methane-detecting satellites with cutting-edge sensors are helping to address these problems. There are already dozens of these satellites in orbit, and more are expected soon. As the number grows, it's vital to understand what each satellite can do, the data it can deliver, and how we can harness this information to meet our climate goals. RMI's new Satellite Point Source Emissions Completeness tool, or SPECT, helps users see how different satellites detect global methane point source emissions. The tool evaluates the satellite data on their detection sensitivity, spatial coverage, and sampling frequency, all key factors we need to pinpoint, quantify, and act on methane emissions. Please visit spect.rmi.org to learn more.